we were looking at the syllabus in the previous class. So I hope you managed to go through the syllabus in leisure at home. So if you had gone through it, we saw that we are going to start with the steel structures. Now, steel structures is one of the most desired construction material for industries because it's fast, it's super quick in terms of moving it from one place to another. For example, you have got a shed here today. Tomorrow you want to move the shed, you can move the shed in one piece. I had a video of one of the, I mean not a video, a photograph with a caption, "Sir, the foundation bolts are missing." So a crane is holding up an entire shed, and then they are coming and looking at the place where they are going to keep it. There is no foundation bolt, and I have also seen structures where they would have erected the entire thing, and two rows of columns will be just suspended. There is nothing to sit on. So one way of looking at it is the fabrication is so quick that sometimes and it's very tolerant to errors. So somebody didn't do the foundation bolt, but still the structure was able to stand. But of course, it's not a good practice. It's not expected of managed engineering organization. But so these are some of the things about steel that we can talk about. Okay. Now coming to our today's lecture, I want to go through and have a short introduction to what are what we have to our designs. The introduction to our designs. Literally, that's what I want to do today. Okay. So I'll just take my notebook. My notes. So again, as I was saying, IS 800 2007 is absolutely required for your program here, and you will need to have some other code books also, especially the steel section tables, because that is what is going to be giving you so many properties which you're going to work with. Okay, so it's 8:05. We will start with our attendance, and okay, so coming to our course, we've got the code book here. I'd appreciate if suppose you go through it. Probably the only term. So actually, whatever we are talking about in our whatever we are talking about is all here. So structural steel, like whatever we are talking about materials and stuff like that, you can just find that it is over here. Again, one of the important things about a code book is it's got its own limitation. Okay, so this is the place. I'm sorry, I still got to get used to this system a little, so I may be going around a little like a drunk. So one of the things that you actually have about a code book is you should know where it is applicable. A code book is not applicable for, it's not a medicine which is for any disease. So in particular, if you look at our IS 800, you're only going to use it for hot rolled sections, and there are a lot of criteria to which this code is applicable. There is a lot of criteria to which this code is applicable. So you just go through the scope. So if you read the scope, you'll understand where this is applicable. And again, we will be going to design. Actually, rivets are literally not in use nowadays. Do you know what is a rivet? You would have seen this in Looney Tunes and other cartoons like that. So you'll find that there is a pin. This pin is going to be kept between two sheets of metal, okay, through a hole. So when they want to join these two sheets of metal, they just drill a hole through it, put this pin through, and then they'll apply a large force here, which will cause the plastic flow of the section, I mean of this pin, to take the shape of the rivet head. Okay, of course you can still see some rivets in the, for example, there's a bus, I mean a chassis standing outside. you'll find that some of the gussets are riveted, and some of the old bridges, especially the Howrah Bridge and all that, the connections are riveted. If you look at the railway wagon, you'll find that there are some of the plates are riveted to the supporting skeleton. Okay, so these are, but this is literally outdated. You too, if you want to talk, use WhatsApp. Please don't talk. Okay, so now what's happening here is this is outdated because this requires a lot of equipment, and other thing about rivets is you can't remove it very easily. You'll really be damaging because it's almost like a permanent connection which you get in a rivet. But today we are having what is known as the high yield strength friction grip bolts. Okay, so HYFG. So these bolts are able to achieve the same property of rivets, and all the other things are what shall I say, all the desirable properties, like you can remove it and then attach it again, all of that is possible. So if you look at bolts, there are two kinds of bolts. Usually you call them as black bolts. Black bolts are just bolts which you use to um, connect to what should we say, they are just like, for temporary holding bolts. Before you actually do a connection, you may just have to hold the pieces in place, so at the time you use the black bolts. Anyway, so, and the other thing is welding. I'm sure most of you have done welding in your workshop, right? So you know in principle at least what welding is all about. Okay, so we will be coming back to the code. We'll be coming back to the code very frequently. For now, I want you guys to read up the first two chapters. You need to understand the scope or the place where the code is being applied, and then the second thing is some of the general principles of how the rivets or how the bolts are going to be connected, how close you can come with two bolts. Okay, how much should the bolt hole be when compared to the bolt. So all of these, and washers, for example, you need to have washers in a steel construction. Washers are a must. So these are some of the things which will be put in here. Again, of course, there is something about welding also. So the first two sections of the code till about page 15, I want you to revise, and I am going to keep a quiz. It will be an online quiz. Again, this quiz is open book. You will have plenty of time, like half an hour to go through it. It's not one of those quizzes like what I conduct for construction management or what I used to conduct for construction management. These are quizzes where you try to evaluate how well you have learnt it. Okay, these all will have a component towards your final quiz, but more than that, this is a quiz to help you to understand the provisions of the code. Okay, so section 1 and 2. So when can we keep the quiz? Today's date is 10th, right? 10th November, sorry, 10th Jan 2017. I'll be sharing a link to this section. Okay, so you can it's as good as whatever I'm writing on the blackboard. You get a copy. Class notes of yours, your own class notes will also help, but this will help you to cross check whether what you've done is right or wrong. Okay, so yes. So when do we have the quiz for section 1 and 2 of code? Wait, come on here, give a date. Can I say Friday? Saturday or Sunday? After, hey, don't keep everything after Pongal. This fellow is there in both my classes and everything is saying after Pongal. So, no. See, the entire code you are going to do in less than about 4 or 5 weeks. Okay, at the most you got 4 weeks. Till CAT only you got this, so you cannot extend it indefinitely. No. Please, let's have it on either Thursday or Friday. I'll keep it as Thursday, 11th, 12th. Okay. So the quiz date is 12th Jan. Okay, Thursday. So time will be between. No, why do you want to ruin your weekend here? Okay, so it will be 9 p.m. to 10 p.m. half an hour. Okay, Okay, so this is something which you can just go through by yourself. Now I'm going to just go through what I want to teach you today. Steel bridges were initially the cast iron bridges. Okay. So cast iron had its own problems. It was a brittle material. Cast iron was a brittle material. So they started to develop the high strength steels, bigger. You want it bigger or something? I mean, right, right. Okay. So the cast iron bridges were very brittle. So they had their share of problems, especially in the cold weather. And slowly, the steel manufacturing technologies increased, and then we had a lot of steel plants coming up, and all the good things happened. You can go through the trace the history of steel. Okay. Now I will just start with one of the significant problems of steel. What do you think is the problem with, now this is cast iron, don't worry about cast iron, we are not bothered about cast iron, we are only going to worry about steel. Okay, so what is the problem with this material steel? Even if you're wrong, it's okay. This is not an interview. You're not going to lose anything because of a mistake. Okay, it will help you develop your public speaking. Do you find that the lights are too bright? Do you want the lights turned off? Tube lights? I think will one of you just please turn off the tube lights? I'll also increase the thickness of my pen. Okay, what are the problems associated with steel? Hey, 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 not all the lights. You guys will make it a cinema theater. Right. Okay, what are the problems associated with steel? What do you know as the known problems of steel? What is the color of steel? Gray. How long does it stay gray? Yes. So, how long does it stay gray? Depends on the atmospheric condition. So depending on the atmospheric condition, steel starts to rust. So technically you will call this as corrosion. Okay, so corrosion is a phenomena which you cannot do anything to arrest. It will happen, so you may have to do some protection. Do you know some of the ways by which you protect steel? Huh? Yes. Yes. So protection of steel is by, yes, you're right, galvanization. Then I'm just going to call painting as surface coating. Okay. In fact, galvanization also can be called as a surface coating. Probably you can make it into stainless steel, and then again you get a lot of protection, but that's very costly. So again, there's one more very important technique called, yeah, electroplating, or sorry, not electroplating, what is that? Sacrificial anode and all the time. Term is just slipping off my mind. I don't. No, no, it's not electrolysis. Sacrificial protection, cathodic protection. Yes. So it's called cathodic protection. Okay. Thanks. Sometimes we. Yeah, I'm just removing this. And yeah, this is the other thing is called the cathodic protection. 1 minute. So cathodic protection is a very important method of protection, especially in oil and gas industry. So we used to do that a lot. All the steel structures, all the cable trays, all the structures will be kept of equal potential, so that there is no chance of corrosion taking place. Okay, so these are some of the ways by which you protect a structure from getting corroded. Okay, so now I'll just ask you to recollect what are the types of corrosion. What are the types of corrosion? Okay, that is electrochemical. This is electrochemical corrosion, what you're talking about. Then Electrochemical corrosion, then you would have heard of the pitting corrosion, no? Heard of this? Pitting corrosion? Huh? Yes, it would have been there. So then you got what is known as the bimetallic corrosion. So if you look at the, actually speaking, what is this bimetallic corrosion? If you are having two metals which are separated from each other by what is known as the in the galvanic series. In the galvanic series, if suppose two materials are very far apart, then they will start to undergo oxidation, then a redox reduction, which is essentially corrosion. Now, bimetallic corrosion is happening because two dissimilar materials are kept together. Okay. If you look at the traction, like electric traction of the trains, the conductor to which the pantograph is attached is pure copper. The other is all some steel which is used to suspend it. So the in between both of them, you'll find that there is a bimetallic connection. That is a material which is not going to affect either of them is used to connect the two materials. So this is something which is very important. Okay. Now, in addition to that, galvanic corrosion, bimetallic, and pitting. So these three are the corrosions which we are very much bothered in steel construction, because you may have to keep two materials in contact with each other. As a structural engineer, you will be told what is going to get supported on your structure. So it means that the moment somebody says I am going to keep something like copper, then you'll start to think, will this cause bimetallic corrosion? So you'll have to take some precautions. Again, you may have bolts made of some other material for some fancy reason. Because you're using that bolt and you're tightening it nicely, the bolt is going to abut nicely on this and start corrosion. Now, suppose you are having the bolt, let's say initially like this, bearing on the surface of the plate. After some time, because of corrosion, what happens? The products of corrosion would form and this place will totally get eaten away. Now after this, what happens to the connection? The connection becomes loose, in sense that only as long as it's pressing against the other, you are going to have contact. Otherwise, what you'll be able to do, you can still tighten it further to make the contact, but then what happens, this is not going to help you in the long run. So this is a very important thing which you have to do, consider when you are looking at connection design. Again, this pitting, when does pitting take place? When it's in contact with water and salts. Okay, the salts can be due to, pure water doesn't cause corrosion. Pure water does not cause corrosion. Because of the impurities in the atmosphere, they all get mixed and then you start to face corrosion. Okay, so pitting corrosion is also a little inevitable because we've got steel piles which are there in the sea. You may have alternate wetting and drying cycles which are inevitable. So this, for this usually we go for the cathodic protection systems. It means that as a structural engineer, you should know that this is an option available to you to protect, because there is only so much you can do with coatings. Okay, the coating can break and that is more dangerous. Now, the other thing which we really need to think about is, we are talking about connections. So we talked that if you use the wrong screw, it is going to cause you trouble. And if there's another thing, 1 minute, significance to connections. Now, one of the other very important things which we have to do is, when you're detailing a steel structure, you can cause corrosion or you can prevent corrosion. Now I'm saying a very specific word. What I'm telling is that you can cause corrosion or you can prevent corrosion by the detailing. Okay, so what is detailing? For example, if you are having a tie rod, what's a tie? It's a tension member. Okay, so suppose you are going to say that the stress which is permissible is say 10 kilonewton per millimeter square. I'm sorry, 10 kilonewton is the permissible load. Then you got a section which will take up this load. Okay, but after you designed a section, you got the required area of cross section. The load is going to be safe. But then what you can do, you can just say, for example, take if you need A1 as the area, you can take a section like this, or you can take a section which is looking like this, or you can choose a section which is looking like this. So all the three could take the same load safely. Now what happens is, if suppose you keep this, this is called as an angle section. Okay, if you keep this angle section like this in this position, what can happen? Dust can accumulate here, moisture will get will also form on this, and then what happens? You will be having corrosion taking place. Instead of that, you could probably detail this like this. You could probably keep the section like this. Area of cross section is the same. In this case, in case 1, case 2, area of cross section is the same. But what is happening? The chance of corrosion is much higher in number 2. Again, in channel, you can keep the channel like this. You can keep the channel like this, and you can keep the channel like this. So 1, 2, 3. Which is better for the which will handle corrosion better? 3. Okay, so again, for this I section, I can keep the I like this, I can keep the I like this. Okay, which is better? 1. Okay, so actually this is some of the things which we have to think about. How you keep or orient element is going to play a very key role. Okay, now I will just share this with you as I remember it. I will be coming back to the arrangement a little later also in today's lecture. See, angle by itself is a very poor section to take loads. So usually you'll keep angles as this pattern. Okay, you can have angles placed in many methods. You can keep angle like this. This is called angle back to back. Okay, so this is called angle back to back, and this is called a star pattern. Okay, this is called as a star pattern. Now, if you look at the back-to-back in this particular case, definitely you are not going to be able to accumulate water. But in this, you will find that water can get accumulated. So typically, what you do is you will be drilling a hole to allow water to drain. If you don't drill that hole, then that is bad. Okay, so we got very complicated base plates. Base plates are the place where the column meets the pedestal. Okay, so for instance, we've got the sections. This is called a cruciform section. Okay, so two I beams are made to sit like this. Now when you're looking at the base plate will not allow, will accumulate water and keep it, store it like a water tank. So we will need to definitely drill some holes to drain the water. So this is a thing which is called detailing. Okay, how you, this hole which you drill is a detail which you add. Okay, so in steel you should always remember the devil is in the detail. I will just put it, devil is in the detail. Now this is not what I have told. Okay, I don't know who has told this also, but this is very true. The devil is in the detail. Now again, of course, there are three other types of corrosion: stress corrosion, fretting corrosion, bacterial corrosion, and also the the hydrogen embrittlement. All the three of all of these you can just know for your personal information. Okay, you can just have this for your information and go ahead. But most of the other three you don't come across so frequently. These are things which you can avoid because of how you do your design. Okay, these are things which you can avoid by how you do your design. Okay, now I'm just going to talk a little bit about sections. Okay, so let's take another color. What is this section? These are the shapes in which the steel is produced. Yeah, these are the shapes in which, or in which steel is produced. How is steel produced? How is steel produced? There is a process called the Bessemer process. Okay, so if you go to a steel plant, the Bessemer chamber, the furnace is there. The furnace, they take the steel out using a ladle. Okay, it's amazing. Every column in the steel plant is about, two of me can play hide and seek. I can actually go and hide between the flange. Okay, so that is the size of the steel. I mean, there is a load which is there for coming on this. So they've got a ladle which takes the steel out of the uh, whatever is the furnace, and then it's poured into torpedoes. You can look at all of these terms online. Torpedoes are bullet shaped compartment. A locomotive will take it to the place where the sections are made. So sections can be rolled, they can be drawn. Okay, depending on what you're doing, you will draw the wire or you will roll it, or you can also press it. Okay, so how is steel formed? I mean, like, how is sections formed? They can be formed by pressing, okay, or they can be formed by rolling, okay, or what was the other thing I told? Pressing, rolling, and die casting. Okay, or it is drawn into wires. Okay, they are drawn into wires using a lot of force, pressed sections are cold form sections which you don't very often see. They are very thin. Obviously you cannot press a very thick section into shape. So these sections are having very have a lot of application in sections like purlins. Okay, what is a purlin? Purlin supports the sheeting. Purlins support the sheeting. Probably we should try to understand the various parts of the steel structure, but that I will do it in the next class, probably with a diagram. It should help better. So now we'll just say that this is a section which is very thin. Now, because it's very thin, it is having a problem of buckling. What is buckling? What is buckling? So if you take your notebook and try to apply a force, you'll find that it twists out of shape. It twists very easily out of shape. So this twisting is called buckling. This twisting is called buckling. Now, buckling is a very dangerous phenomenon because you don't notice when a substance buckles, it buckles very suddenly, very quickly. So it's something which you don't like it to happen. So usually they'll keep something called lips in the section, okay, and they'll also press some sort of shapes to make it more stable. Okay, so when you're studying about cold form steel sections, you will probably come across all of this: lipped section, channel section, hat section, so on and so forth. Okay, so then the rolling process is it can be hot rolled or even cold rolled, which is nothing, which again comes to the pressing only. So hot rolled sections are what we are more bothered about in this course. Hot rolled sections are what we are more bothered about in this course. So what is hot rolling? The steel in a very hot condition is passed through rollers. The rollers will slowly reduce the thickness to the required dimension. The rollers will slowly reduce the section to the required dimension. Now this is IS 808. This is IS 808, and IS 808 is for hot rolled steel beams. That is, these are the sections to which the sections will be made if suppose they are coming to Indian standard. Now you just have a look at this. These are all terms which you know. Okay, so AB is fine. Okay, I don't know how to get rid of this part. Fine. So you know what is area of cross section? Cx Cy, that is Cx Cy centroidal distance, and other things which are there. Again, E, X and EY are important terms. If you remember, what is this depth of neutral axis in a concrete section? It is the distance of the extreme fiber in compression. Okay, so you are looking at a compression fiber in steel, in concrete, only because concrete can only take compression. How much tension can concrete take? How much tension can concrete take? Negligible. Zero, yes. From a design aspect, it is zero. You're right. So negligible that you can even take it as zero. Both of your answers are perfectly right. Okay. Now I will also ask you to look at this particular portion. Here you'll see that something called UU and VV axis is there. These are called as the principal axis. Do you remember going through the principal axis? In any case, when I'm just taking one of the sections, I will explain it to you. Just refresh your memory, please. Again, M, mass of section. What is the significance of mass of section? Usually what they do is they give the weight of individual section as kilogram per meter run. The load is given in terms of kg per meter run. So if suppose the person next to Deepankar, yeah, if suppose I am going to have a section which is weighing 10.2 kgs per meter, and I am going to have 10 such sections, each 5 meters long, what would you infer from that? You will be saying that this roof has a member which is 10 kg per meter run. 5 such members make up the roof, and each is 10. So you just multiply it, you can find out the weight of material which is required. Okay. And at this point, I'll also just tell you that whenever you order steel sections, don't be so accurate. There's something called cutting wastage. How many of you have cut metal with in your welding class workshop? Have you cut metal, sheet metal? Have you seen? Using sheet metal using gas cutter. Did you use a gas cutter? What did you use? Have you seen gas cutting being done? Okay. What happens when you cut material with a gas cutter? Usually, when you cut metal, you'll find that if this is the material, you'll find that around the width of the flame is lost plus some other material, right? So this is the cutting wastage which you have. Suppose your rolled steel section is 12 meters long, and you are going to have a roof which is 10 meters long. What will you do? You will have to buy only 12 meters long section and cut the 12 meters to 10 meters length. What will you do with the remaining 2 meters? That is scrap. It becomes scrap. Okay. So it means that when you order steel, don't be so accurate. You need to be a little you need to understand how it's going to go. Okay, I'm running a little out of time. I'm going to rush a little here. So now if you look at this, coming back to the code book, you will find that the sections are having the properties which you know. This is IS 808. Okay, please go through the properties. Section modulus. What is section modulus? Modulus of moment of inertia. Okay, shear center and all these things. Principal axis and neutral axis. These are some of the things which you just have a look at. Again, radius of gyration is also another important term. Okay, coming here, if you look at this steel section, this is a rolled steel section. This is the web of the section, and this is called as the flange of the section. If you see, there are always some it is not a right angled section. So these are advantages because it will not allow water to stay, but the problem will come when you try to bolt it. When you try to bolt it, there is not a flat bearing surface. Okay, but in any case, you got the x-axis and the y-axis. These are the centroidal axis of the section. These are the centroidal axis of the section. These are all various sections, like heavier sections in the sense that the flange is much heavier in some of them. In some of them you'll find that the web is thicker. Why is it thicker? We'll come and have a look at it a little later. Now here in this section, x-axis and y-axis is given here, and you will easily understand that cy is the distance of the centroid from the edge here. Now I'm coming to the angle section. Now if you look at the angle section, you are having x-axis and y-axis. These two are the centroidal axis. In addition to that, you got the u-axis and the v-axis. You got the u-axis and the v-axis. Now what is the u-axis and the v-axis? These are the principal axis. Okay, these are the principal axis. So now I am having the I'm having the x-axis and the y-axis. What is the centroidal axis? What is centroidal axis? It is the axis through which the mass is concentrated. Okay, that is, if I'm going to just suspend it here, it is going to be perfectly balanced. Okay, so this is the centroidal axis. Now what happens in this is, if suppose I'm going to apply a bending moment about this axis, the stress distribution would be such that it will look something like this. Again, there will be bending in both the axes because of the because it's unsymmetrical. Actually, okay, so you'll find that the material is not utilized fully. Now, where will the stress be maximum? Here or here? Where is the stress maximum, or are they same? Extreme fiber stress. See, both of them are balancing the load. This is having a shorter lever arm, this is having a longer lever arm. So which longer length will have lesser value of force? Small force, yeah, even stress wise it is lesser. If force is less, stress is automatically going to be lesser. Okay, so this means that the material is not properly utilized. Okay, so this is one of the things. So you suppose you are going to, but on the other hand, load it about the principal axis, UU and VV, you will find that that this problem will not happen. But it's very difficult to reorient it to this angle and then do the loading So it is usually not done that way. Okay. Now next I will stop here. I'll continue on in the next class. Okay. We will just try to understand the various types of sections and try to bring out what is the demerits. Okay, demerits. And I actually wanted to do one more thing here. I wanted to ask you guys to work out the moment of inertia of a simple T section. Okay, but because we don't have time here, I'm going to give another homework here. So this homework you need to do it today, and by today or tomorrow I'll be having Moodle put up. Okay, all of these assignments, all these homework are peer reviewed. Okay, you have to review somebody's work, somebody will review your work. For this I'm only giving 2 peer reviews. Okay, 2 peers to review, and you will have to actually what shall I say? Shall I give everybody the same thing? Actually, this is fine. You can all do the same thing. This is very fundamental, but I want you guys to please do this. Okay. So this is a T section, and what will be this distance? 75 mm. Okay, and what can I keep this length? 125 will be too small here. Okay, say I'll keep it as 300 mm. Okay, and then I will keep this 100 will be again less. Okay, because see, always visualize as engineers. 300, if I want to make it look at as a T, 100 is 1/3 of that. Okay, so let us make it a little longer. So 230, no, this portion being 230, not reasonable. This is 75. So here what we'll do, we'll keep it as 800 at least. Okay, as 800, and then this stem I'm going to keep it as again, okay, 75 mm. Okay, all dimensions are in mm, and because actually I'm not adding the Moodle page right now, because I'm still expecting 1 or 2 people to join, because yesterday was the last day for paying fees. They extended it, so probably we may have a few additions. I don't want to be going up and down doing the same work over and over again. So thank you very much. Okay, I hope you found this session useful. You will find that you are going to remember a lot of the things which you have learnt in the previous classes being applied in design. So whatever we have studied earlier, each and every part of it is useful. If you have any doubts in what we have done today, you can please ask it now. Okay, so what we have done is we've seen very not too much. We saw what is the ways by which steel is produced. Okay, and yeah, we try to understand why devil is in the detail. You can arrange a steel structure in so many ways. Okay, and then we saw the types of corrosion, and yeah, how we can protect sections. We also opened the code book a little, and we are told that there is a test on Thursday. Okay, this is, yes, IS 800. This is IS 800. IS 800 2007. Okay. Soft wait.